Good morning. Welcome to the session of Instrumentation Engineering. Today's discussion topic is study temperature, pressure, flow, level processes and construction of the PNI diagram in accordance with ISA guidelines and standards. Myself, Somak, Assistant Professor, Department of Instrumentation Engineering, Haldia Institute of Technology. So before I proceed to the discussion of an PNI diagram, first of all, we need to know that what are the things already we have discussed about the block diagrams, where the drawbacks we are getting and why should we need to go for PNI rather than we will go for block diagrams. So in this block diagram, which is a very known block diagram to all of us, which is known as feedback control loop, in this the process is there in this particular block representation. The process can be the different types of process we can understand. Obviously, as an instrumentation engineer, we need to measure the parameters. 4 parameters already I told you, that the pressure, temperature, level and flow. And in the practical circumstances, we need to take under the consideration of a disturbance, because in practical industries, the disturbance is a very common fact to all of us. So if we are measuring any one of the parameter from this process, so obviously we need to get the measuring instrument or sensor, which is also known as transmitter. So in the feedback path, here you can see the measurement sensor or transmitter is associated at that particular area. So the measuring instrument or the transmitter will measure the feedback, measure the parameter of the process and give it to the feedback path with the summation block in which the set point is given. The set point is provided by the operator from the control room, and that will be validated in this summation block. If there will be mismatch, so obviously error will be generated from this particular area, and this error will be transferred to the controller section, and obviously the mathematical calculation and the corrective action will be taken by the controller. This controller section, then the control action or the controller output will give it to the final control element. Obviously, this final control element takes the responsibility to implement the changes what will be required to get the desired set point in the process parameters. So if we are talking about this particular feedback control loop, so all the controller, final control element, process, measuring instrument or transmitter, they all are provided in this particular diagram by a block. So using this block, it is very much problematic to us to know or understand that is there a temperature control loop, is there a pressure control loop, is there a different type of control loops, in which in a practical industry we have 1,000 loops which is conducting at a time. That means using these blocks we are not getting enough knowledge about the process as well as the loop, and what is the parameter we want to measure, that also cannot be addressed. So in these circumstances, we need to go for a different diagrams through which the instruments can be identified, the signals can be identified, which will transmit from one end to the other end of a process. And if we have 1,000 of loops in our hand, in that case also all the information need to be given in a specified way, not like these blocks. So that's why we need to go for PNI diagram, which is known as piping and instrumentation diagram. This renowned methodology or renowned pictorial representation is come into the picture of the instrumentation in the initial day of the industrial growth, in which it will come to the picture that without PNI diagram, the information cannot be transmitted very clearly to the different parts of the world. That means the worldwide acceptance of different symbol of instruments and the signals need to be standardized first. So in this particular slide, one by one point, I try to go through it and try to describe with you. In an industry, processes can be described and understood by the use of the piping and instrumentation diagram. So as I already mentioned to you, without this piping and instrumentation diagram, the clear and quick knowledge cannot be given to the audience or the instrumentation engineers or the engineers who are associated with the industry. That can be only given by this PNI diagram rather than we can use for the block diagram. The second point gives us the information that the purpose of the PNI diagram is to provide quick, systematic, and reliable information for process analysis, production control, specification of the equipments, and preparation of the equipment requisitions. That means the pictorial representation of a diagram need to be quick enough, systematic, and reliable, through which the information one need to be given to the different audience that will be clearly understood by them. That can be help us for the production analysis, production control, or if you want to make the extension of my project of any industry, in that particular case we can say it is a blueprint through which the installation, the commissioning, the startup, and the production, all that can be identified, that how the things can be done one by one. A very good example is given in the point number 3 is that it is very much similar to the electrical scheme. That means if we just think about a electrical circuit, in an electrical circuit, if we have a source, we can easily identify by the symbolic representation that it is a voltage source or a current source. It is the resistor, it is a capacitor, or it is an inductor. So using the symbolic representation, if we can identify all the things in electrical circuits, so the control industry, especially the chemical and the process industry we are talking about, describe its plant and their instruments by an PNID. So it is nothing but a type of electrical circuit which is implemented into the background of instrumentation for the process plants. The PNI refers to the detailed drawing of a plant layout that includes the pictorial representation of the entire piping and instrumentation block used in a plant. So as I already mentioned to you, obviously the instruments which are using over there, that need to be identified clearly, and how from one instrument to the other instrument is connected, how the signal is transmitted. Is that an electrical signal? Is that a pneumatic signal? Is that a hydraulic signal? That need to be identified by this PNI. The second last point which we need to consider over here is who will standardize the symbolic representation of each and every instrument. So here one of the institute and one of the society will come into the picture at the initial day of the discussion of PNI, which is the American National Standard Institute. Shortly it is known as ANSI, whereas the International Society of Automation, which is known as ISA, they are standardized each and every symbol which will be used for the PNI diagram. Not only the instruments, also the signals. The electrical signals is standardized, the hydraulic signal is standardized, the pneumatic signal is standardized. And also in our India, we have the equivalent Indian standard is also available. But it is a worldwide acceptance of the PNI diagram, and the standardized symbol need to be used in India, which can be represented in USA, which can be represented in China, which can be represented in Japan. Wherever you just go and give your PNI, so every instrumentation engineer, those who are associated with this PNI, they can easily visualize and identify that what type of mechanism you want to implement in your industry, what type of instrument you want to install in your industry, what type of signal you are transmitting from one end to the other end. So language cannot be a barrier over there. The last point, it describes and specify how process control engineer requests are represented in a PNI diagram. So you no need to use your words. Your diagram will tell all the things, that what is the thing, what is the implementation will be associated with your industry, what will be your requirement, how the requirement can be done, which type of instrument you want to install to your industry, that will be identified. Now, what are the components of this PNID will be required? So first of all, just think in that way that if you have a large plant, So in that case, thousands or lakhs number of instruments will be there. And if lakhs number of instruments you have, that means 1,000 or more than 1,000 numbers of loop is operating at a time. And it is a huge task. So for each and every instruments need to be identified by their loop number or tag number. The loops need to be identified by their loop numbers. The instruments need to be identified by their tag number. And from this tag, we can identify all the information. Just take a very simple example that in a class, we are giving the roll numbers of each and every student. So from this roll number, if you want to get the information, I can get the name of the student. I can get that in which semester he is, and whatever the characteristics of the student, is a good student or a bad student, what type of reflection he is given in the entire period of his studies. So different types of information I can gather from only his roll number. So here also the same thing. That means from a control loop number, we can identify which type of loop it is. It is a temperature control loop, or it is a pressure control loop, it is a rather level control loop, or different types of loop. From the instruments tag, I can identify that this instrument is associated with which type of control loop, that also can be identified. All the interconnection lines distinguish between the types of interconnection. So now, as I already mentioned to you, not only the instruments, the connection between the one end to the other end, is that the connection of a electrical signal? Is that the connection of a pneumatic signal? Is that the connection of a hydraulic signal? That also can be identified by this PNI. Not only that, also the final control element, the control valves, that is also will be there in the pictorial representation or the symbolic representation of a PNI, in which from the control valves, we can get the information about which type of valve it is, the type of valve action, it is here to open or here to close, it is fail-safe features is associated with it or not, flow pressure, flow plus pressure information is given it from the control valve or not. So all the information we can get it. The range of all the safety valves, that also can be identified by the PNI diagrams. The pressure regulator, if you are using, which type of pressure regulator you are using, and what is the range of this pressure regulator, that also can be identified. Lastly, all the sensing device, the recorder and transmitter, that also need to be identified by their tag numbers in the control loop. So not only the loop numbers, the instruments also need to be identified by their tag numbers, through which we can identify that this particular instrument is associated with the temperature control loop, this particular instrument is associated with the level control loop, this particular instrument is associated with the temperature control loop. So which I just told you, this is given over here in the transmission lines. So if you have in your PNI a very continuous line, so no need to think about, and please take it under the consideration that it is process connection, nothing but a process connection. If we are representing a pneumatic signal, the pneumatic signal will be represented by a continuous line and a double cut into it. Electrical signal is provided by the dashed line. The hydraulic signal is represented like this. The capillary tubing will be represented like this symbolic representation. Electromagnetic signal will be the continuous line. After that, the sinusoid type of representation need to be provided over there, through which we can get the information that it is an electromagnetic signal. If some software link or data link is connected between the two ends, so in that case, the software or the data link will be represented by this. If this is the connection between the two mechanical machines, in that case, the mechanical link will be described in the PNI like this. That means for each and every signal, we have the different representation. That means without talking much more, using the diagram, we can get the information about it. No need to talk and no need to think about the transmission lines. So easily we can identify it. Not only the lines or the connections between one end to the other end, also the standardized instrument symbol need to be identified from the PNI diagram. So in the column, if you just see, it is written accessible to the operator primary. That means if you have the idea about the HART protocol, two of the operators we are talking about. One is the primary master, another one is the secondary master. The primary master is mainly associated with the control loom, who is sitting in the control loom. And the secondary operator is associated with the maintenance team, who is going to the field and try to check the instruments. So now also the field location or the field locating instrument will be represented in a different way in the PNI. And also if any instrument is inaccessible to the operator, then also that will be represented in a different way. So first of all, in the first row, if we just go here, you can see this is the discrete instrument we are talking about. If we are talking about a discrete instrument, if you are talking about a temperature measuring instrument, if it is accessible to the primary operator, then a circle, and in the middle we need to make a continuous line. If it is only a field locating instrument, then it is only a circle, nothing else. If it is operated by the secondary master or the secondary operator also, then the two line need to be drawn at the circle. And if it is inaccessible to the operator, that means it is nothing but accessible to the engineering station, then it will be dotted in the middle. In this way, if you go, you will get the information that the shared display or control. So the control unit, if it is associated with the display, then all the above symbols will be there. And after that, if it is display type, then a box will be need to be drawn over here, through which we can get the information that it is not only the control area, here the display unit is also available. If it is computer function, then the representation will be changed at that particular area. If it is a PLC, programmable logic controller, we are using in our PNI diagram. So in that case, the representation will be look like this, which is shaped as diamond. So please remember, when we will go to draw the PNI, that particular things also need to be take under the consideration of the standardization instrumentation symbol. Now it is a very important discussion of this particular part of PNI is we are giving you idea about some of the elements and how they can represent in the symbolic representation. So here, as I already mentioned to you, that the different types of valves we have in the practical industries. If it is a gate valve, it is a needle, it is a four-way, angle, diaphragm, manual operated valve. Different types of valves are represented in a different way. If it is a globe valve, if it is a butterfly, three-way valve. So different valves are represented in a different symbolic representation standardized by ANSI and ISA. If it is a solenoid control valve, if it is a motorized valve, then the representation will be something different. Here the motorized control valve representation will be given. If it is a pneumatic control valve, mostly in many of the industries, it is a very popular type of control valve, which is a pneumatic control valve. If you are using a pneumatic control valve, the symbolic representation will be look like this. If we are using the flow measuring instrument rotameter, then the representation will be looked like this. If the safety valves we are talking about, that will be represented like this. If we are talking about orifice, the representation will be looked like this. If we are talking about turbine, if we are talking about centrifugal pumps, if we are talking about rotary compressor, then all the representation will be different from each other. So if one of the symbolic representation I put it into my PNI diagram, so easily that can be identified that this is the representation of the orifice, nothing else. So there will be no confusion that it is a rotameter or orifice. So we no need to think about if this representation of the symbolic representation is given into the PNI diagram. So easily we can say it is nothing but the representation of our orifice. So that's why, as I already mentioned to you, quick, it is reliable, and obviously it is the systematic representation through which we can get all the idea about it. Now, one point which I already mentioned to you about the tag number and the loop number. So if I have a lakh number of instrument in an industry, so easily we can say this lakhs number of instruments is associated with 1,000 numbers of control loops. Maybe the one of the loop is temperature, maybe another loop is flow, for another loop is using for level or different purposes. But we need to give this tag number and the loop number. So here we have take an example through which we try to understand. This is written over here as TIC 103. What is the significance of this TIC 103 if we want to get it? It is written that instrument identification or tag number. So from this tag number, what information I can absorb? So first of all, T103 will give you the information of the loop identifier, which type of loop it is. The first letter and the number will give you the information is that which type of loop it is. T stands for temperature. 103 is the loop number. That means this 103 loop is associated with the temperature measurement and control. That's why T, capital T, is associated with it. 103 means it is nothing but the loop number we are talking about. TIC, these three letters will be known as the function identification, in which the first letter T and IC is called as a succeeding letters. In the next part, we try to get the idea that what is the full form or the full information we can get it from this TIC, in which T is the first and IC is the succeeding letter. So if I just go to the next slide or a next discussion, here you can see we have a table through which all the information we can get. That means here we have a first letter, we have a succeeding letters, and it will start from alphabets A to alphabetical order Z. So already we talk about TIC, we try to identify what is the meaning of this TIC. So come to T first. T means temperature. After that, I, if we go, we cannot take current because current is the first letter. We need to go for the succeeding letters. So the succeeding letters is indicate. And again, C is also the succeeding letters, that means control. So if we join these three words, it is temperature, indicate, control. So TIC stands for temperature, indicate, control, and the loop number is 103. In that way, if we just go for TT, which is a very popular name, T means temperature, and again another T will be the succeeding letter, means transmit, temperature transmit, or we can easily say knownly name as temperature transmitter. If we go for PSV, so if I go for P first letter, this is pressure. S is nothing but the succeeding letters go for switch, and V, if we go, then the V means valve. That means pressure, switch, valve. If you get anywhere PSB, so please remember it is nothing but pressure, switch, valve. That means using this particular, just a minute, using this particular table, we are able to get all the knowledge about the different types of words which we are using into the PNI diagram. So if you have a table, easily you can get the information about it. No need to think about. Please go through that which is the first letter and which are the succeeding letters. After that, easily you can find out that what is the meaning of that particular part of the area which is given in PNI. Now we are taking 4 of the example through which try to get the idea about the loops using the PNI diagrams. So first of all, the PNI of a temperature control loop, we show it to you over here, in which a process is flowing through this chamber, which is nothing but a heat exchanger, in which the temperature is increased by the steam, and after the heat is exchanged over here to the process, the steam will condense. So here, without any confusion, we can say that here the temperature we are measuring, and TT from the, again, if we just try to find it out from the table, it is TT means temperature transmitter. So temperature transmitter will get the information that how much temperature is there, and after that this signal is representing nothing but the electrical signal. That means this temperature transmitter output will be given in the form of an electrical signal to TC. If you don't know about this TC, it is already written over here. It is temperature controller. T is the first letter, C is the succeeding letters. From this temperature controller, the necessary action will be taken and it will provide it to the final control element, which is the valve over here. One thing we need to take here, that an error will be there in this drawing PNI diagram, is that this is nothing but the representation of the symbolic representation of a pneumatic control valve. But here the signal which is provided, this is the electrical signal. So it is not the correct way to represent the PNI. So if you are an expert, so you can easily say that the pneumatic control valve cannot take the input of electrical signal. So that need to be changed and the signal need to be given as a pneumatic signal. So using this a very short representation or a diagram, we are able to get the knowledge about this loop. We no need to talk, we no need to write it in a box, which is the block diagram concept. No need to go for it. Every information you can get it easily by this PNI diagram of a temperature control loop. Now, if I just go for the next discussion, it is the discussion of a pressure control loop. And in this pressure control loop, we have a gas vessel over here. And in this gas vessel, obviously, we need to maintain the pressure of this gas vessel. So what transmitter we need to use over here is, without any doubt, we can say it is pressure transmitter. And here it is written 103. This is nothing but the loop number. Again, please take it into your consideration. PT is nothing but pressure transmitter. So using this pressure transmitter or pressure sensor, we are monitoring the pressure of this gas vessel. After that, the signal, again, electrical signal is provided to the PIC. If you just go for the table, you can identify that this PIC is nothing but pressure indicating controller, and the loop number again will be same because they are continuing in the same loop, which is the pressure control loop. And after that, what is the error I just told you in the last slide, that is corrected over here, that here if there is the pneumatic control valve we have used, then the pneumatic signal need to be given to the input of this control valve, not the electrical signal. It is PCV, pressure control valve, and it is also will be the same tag number or the loop number of 103. Without this loop 103, which is the pressure control loop, we have HV105. If we just try to get the knowledge about it, it is the hand valve 105. H means hand, V is the succeeding letters which give us the information valve. So hand valve 105 is associated over here for the safety point of view. Also, another valve will be there which can be the safety valve or the release valve, which is pressure switch valve. Already I told you about this PSV in the discussion of the table. So PSV means pressure switch valve 104 is the loop number of that particular valve. So here not only 103, 105 and 104 also associated with this pressure control of the gas vessel. So if we go for the next part, it is a very interesting one for the flow control loop using PNI diagram. So here, as I already mentioned to you, when I show to you about the elements, the representation of the elements of PNI. So in that time, orifice will be represented like this. So we just try to make that how much flow will be there in a pipeline. So orifice is need to be installed over there. After that, FT, this is the flow transmitter or flow sensor, we can say. And one interesting fact is that this loop number is 1982. That means what I just told you, that not only 100 or 200 loops we need to handle, maybe we need to handle more than 1,000 numbers of loops if the plant is huge one. And one thing, this flow transmitter gives the output of this transmitter, the electrical signal, and it will be given to FIC, flow indicating controller. And if this rectangular box is associated over here, that means here this flow indicating controller is also associated with the display unit. Another important fact is that here FY is associated after the flow indicating controller. FY means it is flow auxiliary. That means if this control valve is a pneumatic control valve, that means we need to give the signal of 3 to 15 psi. But mostly from the controller part, the output is provided in terms of voltage or current. So voltage and current is the electrical signal, pneumatic signal is 3 to 15 psi or air pressure signal. So in that case, someone need to take the responsibility to convert this electrical signal to the pneumatic signal. So here this conversion will be go through by this flow auxiliary. Loop number is not changed. Mostly in popularly known as I2P converter, current to pressure converter, through which the 4 to 20 milliamps current signal from the controller output will be converted into the pneumatic signal over here in the flow valve. So here you can see the flow valve is associated over here. Lastly, if we just go to the discussion of the PNI diagram of a level control loop. So again, we have a tank and some feed will be given over there, maybe any kind of liquid, maybe oil, maybe water, maybe anything, we can take it under this consideration. And here you can see that LT is associated over there. This is nothing but the level transmitter. From this level transmitter, electrical signal will go to the level controller. In the level controller, from the control loop, the operator can give the set point value. After that, it will validate over here. Error signal will be generated, and from the error signal, respective control action will be generated, and the controller output again will go to the final control element. If it is a pneumatic one, then the signal again need to be given to the pneumatic signal, not the electrical one. So from a very short descriptive diagram or a pictorial representation, we are getting much more information rather than the information we can get it from the block diagrams. So easily we can say that for the last few decades, we are using this PNI diagram, which help us to give the information properly using the pictorial representation. No words need to be described. If the person is knowledgeable about the PNI diagram, if you know about the PNI diagram, so any person in any side of this world, if I just send him this PNI, he can easily identify what I just try to tell him through this pictorial representation. So there will be no foundation of the languages also. So that's why using the block diagram is not even any kind of acceptance in the practical industry. Only the acceptance can be there of this piping and the instrumentation diagram for the initial day of the instrumentation engineering. So thank you. That's all for this discussion. We'll meet in the next part of the discussion of process control. Thank you.